Okay, so in question 4, we're looking at another scaling question. This is on the topic of scaling. This time on log plots, so very similar to some of the previous questions in the practice exam. I think the one on leaf mass was pretty similar. So this time we're looking at a bird's cruising flight speed versus its mass. So there is a scaling relationship that is sort of been measured, and it's about a sixth. So the cruising speed scales with mass to about the 1/6 power, which is about that 0.17. So that's what we sort of can tell from this graph. So it's a linear log plot. So we've seen these practice exams before, and that tells us that the quantity that's logged in the quantity that's in the parentheses, so the quantity that's logged on the y-axis scales with the quantity that is in the parentheses that's logged sort of on the x-axis to the power of, in a sense, the equal scales to the power where the power is equal to the slope. So from this particular log plot, I can tell that this cruising speed scales with mass to the 0.1718. So that's just like, in a sense, same sort of it's obviously a biological context, but it's no different than saying that area scales with L squared or area scales with R squared for a circle. So in a sense, we have a scaling relationship between one quantity, the cruising speed, and with the scaling with the mass of the bird. So it's a positive fraction. So as the mass of the bird increases, so will its cruising speed. But it's a fraction less than 1, so it won't scale that quickly. So what we have here, in a sense, is that we're told we have a bird A of mass m and bird B of mass 2m. So we're changing the mass by a factor of 2. And then we tell you what the cruising speed is of bird A, so what's the cruising speed of bird B. So if we raise the mass by a factor of 2, then the cruising speed will scale by a factor of 2 raised to this power, and then we have to consider the cruising speed of bird A, which is 8. So if I'm doing this sort of shorthand, and I'll do sort of longhand a little bit later, so the cruising speed of B would be 2, so the factor by which its mass is more than A's raised to that power times the speed of A, which is 8 meters per second, and that should give you 9 meters per second. So that's sort of, in a sense, that if I had asked you the question, suppose that you have two circles, one of radius r and another one of radius 2r, what is the, you know that this area has, and let's say this, so the sort of equivalent question in geometry would be, let's say, suppose that we have a circle, let's say maybe I'll do x, which has an area of 8 centimeters squared. What is the area of circle y, which has a radius of 2r? So you can think about that yourself, and like the steps that you will go through. So you know that, in a sense, that area scales at r squared, so the factor by which I change the radius, that's the factor by which the area changes. So this area here would be 4 times the area of this, of circle x. So 4 times 8 would be 32 centimeters squared. So we're doing the same sort of steps here, same mathematical steps, but it's in the context of a biological context of sort of bird's cruising speed. So again, the same thing here is that we've got a scaling relationship between here VC and M. So as I'm changing the mass by a factor of 2, then the factor by which the mass changes times that initial velocity would tell me the velocity of bird B. Slightly more mathematical, hopefully I can fit it in here. Technically, if we want to write this as a linear equation, like an inequality instead of proportionality, is that VC would be equal to 10 raised to the intercept, so this is the base of the logarithm, so 0.0052 times mass at 0.1718, and this is basically 1. So if the bird has no mass, it should have no cruising speed. So this is really just VC equals m to the 0.1718. So what I can say is that VC of bird A is m to the 0.1718, and then let's move the camera here. Then VCB is 2m raised to the 0.1718. But I can take the 2 out and sort of separate this and write this as 2 raised to the 0.1718 times m to the 0.1718. But m to the 0.1718 is VCA. So this is going to be 2 to the 0.1718 times VCA, which is exactly the shortcut up here. I replace the VCA with 8 meters per second. And we of course end up with the same, but if you're comfortable with scaling, you don't need to do all of this mathematics. Since it's a scaling relationship, I only need the proportionality. We're not, in a sense, I know by the factor by which the mass changes, the equation, the log-log plot tells me how the cruising speed changes with the mass. So if I know the factor by which the mass changes, I'll know the factor by which the speed changes. So it's going to be that factor by which the mass changes raised to the power of basically the slope of the log-log plot times the speed of bird A to give us the cruising speed of bird B. So 9 meters per second is the correct answer for question 4. And then of course I think the other version was I think 6. Again, if you follow the math, I think in both versions the mass was doubled, but the cruising speed was different. So if you replace the 8, I think, with 6, you should find the correct answer for that second version. Okay, I'll follow up with next with question 5.